Hi guys, here are your notes for 7-4. We're going to use the things that we learned yesterday, the angle, the side, and side, to give us a couple new theorems and then be able to solve a couple more things. So the first theorem is the triangle proportionality theorem, and it says if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So we kind of already know this. Like if I gave you something like this yesterday and told you that these two things were parallel, we would take the distance of AE and divide it by the distance of AB and double check to see if AF and AC are the same. But what this theorem tells us is that this divided by this equals this divided by that it's proportional if those lines are parallel. And then the converse goes the other way around and says if these are equal and these are equal, then our conclusion must be that these lines are parallel. So you'll get some problems like this. So this one tells us that these lines are parallel with the red arrows here, and we need to find Pn. So this is x here that we don't know. Because we know that these are proportional, we can set up a proportion like we've been doing. 3 over x has to equal 2 over 5. And remember, there's tons of ways that you can set this up, but just make sure it's consistent. You could do 3 divided by 2 equals x divided by 5. You could do x divided by 3 equals 5 divided by 2. But whatever way you do it, when you cross multiply, you should end up with this. 15 equals 2x. And then if we divide both sides by 2, we end up that x is 7.5. So that's the distance from P to N. The other type of question you'll get is kind of the opposite, where it's saying prove that AB and DE are parallel. Now in order for them to be parallel, these things have to be proportional to these things. So that's what we're going to double check. It tells us that A to C is 36. And it tells us that B to C is 27. Now I need to know the distance from A to D to see if this works. So if the whole thing's 36 and D to C is 20, that means that A to D must be 16. And then we can do the same thing here. If E to C is 15 and the whole thing's 27, this guy's got to be 12. So then what we're going to check is that 16 divided by 20, see if that's the same as 12 divided by 15. And just like the last one, there's tons of ways you could do this. You could do 16 divided by 12 equals 20 divided by 15. As long as you're consistent, it doesn't matter. So there's a couple different ways that you can do this. You could simplify the fractions, or you could cross multiply to see if they're the same. Since these are easy numbers to simplify, I'm just going to simplify the fractions. 16 20ths, 4 goes into both of them, so it's 4/5. 12 15ths, 3 goes into both of them, and it's also 4/5. So we know that they're equal. So if these guys are proportional, then AB has to be parallel to DE. Alright, here's another theorem, postulate, corollary, whatever you want to call it, and a new problem. So this says if 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally. So this says if you have a lot of things that are parallel, that these things here have to be proportional. So AC divided by CE has to be the same as BD divided by DF. So you can get a problem like this tree one here. All the trees are parallel, so these are our parallel lines here. I need to find the measures of LN, LM, and MN. So let's make them some things. L to N, so this total distance here, we can make that X. L to M, we'll make that Y, and then M to N, we can make that Z. So we can't solve for all of these at once, but we can solve for one at a time. So the first one I'm going to solve for is x. So I know that x has to be proportional to this total distance up here. So 1.4 plus 2.2 is 3.6. And then I got to set that equal to something else I know. So I know the distance from A to B is 2.4 and the distance from K to L is 2.6. Now the 2.6 has to go on top because this is all the stuff on the bottom of the trees and this is the stuff on the top of the trees. And then we can do some cross multiplying, or you can simplify, whatever works best in your mind. But if we cross with the x, that's a nice easy one. The other one we'll have to type in our calculator. You get 9.36. Then if I divide both sides by 2.4, I end up with x has to be 3.9. So that's the distance from L to N. So now let's solve for y this time. So y matches up with BC up here, 1.4. And then I can always set all of these equal to this because this is a good proportion. I know it's proportional to all of the other pieces of this. And it'll just make our lives a little easier. So 2.4y, we'll do the other one in the calculator. This time it equals 3.64. And when I divide, I get 1.52, we'll say. And that's the distance of LM. And then our last one is MN. So this here and this here have to be proportional. So Z over 2.2 has to equal the 2.6 over 2.4. Cross multiply again, so we get 2.4Z equals 2.2 times 2.6, which is 5.72. Divide by 2.4, and we get that Z is about 2.4, which was MN. Alright, last theorem. This one has to do with angle bisectors. So this says, in a triangle, an angle bisector divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So I'm going to take a triangle. You don't need to draw this. And I'm going to cut this angle directly in half so that this guy and this guy are exactly the same. Now when that happens, you have your legs here, and you have two sections that you divided here. Now this theorem says that x divided by z has to be the same as y divided by a. These two divided equal those two divided. So when you get one like this problem here that they tell us, we see that it's an angle bisector. We're going to divide these two and set them equal to those two divided there. Now make sure when you do this, like if I put 10 on top here, that means 14 has to be on top here because these are both legs and these are both like the bottom cut in half. And now this one's a little trickier to solve because it has some x's in it, but we still want to cross multiply, so we got to make sure we distribute. And then this is just an algebra problem. So we get 20x plus 10 equals 14x plus 28. If I subtract 14x and subtract 10, divide both sides by 6, I get x equals 3. Pay attention to what the directions asked us. They did not ask us for x. They wanted RV and VT. So we got to plug this in. RV is 3 plus 2, which is 5. And VT is a little more math, but it's 3 times 2, which is 6, plus 1, which is 7. And then double check that this works. 10 over 5 is equal to 14 over 7. That's definitely true. Both of those simplify to 2. So you have some IXL to work on that goes along with this, and when you get done with that, you could work on old IXL if you haven't finished that, or the worksheet that I gave you yesterday. Hopefully I will not see you tomorrow, and maybe not even see you on Friday. So pray for lots of snow tonight. Have a good day. Be good for the sub.